The glide slope is not created by the FMS. It is in the database supplied by Jeppesen. The FMS will take the data and create the glide slope indications on your flight instruments. For RNAV approaches with a level of service of LPV or LNAV-VNAV, the FMS will use satellite geometry to calculate the charted altitudes. In all other approaches, the FMS will use barometric altitudes. Sometimes pilots notice a difference between the ILS glide slope and the FMS glide slope using the barometric altimeter. Remember that the barometric altimeter is influenced by temperature, and unless it happens to be an ISA standard temperature, the glide slope will not be in line with the ILS, which is unaffected by temperature. The flight path angle of an approach is generated in one of two ways. One method is to start with the threshold crossing altitude for the runway, the altitude at the final approach fix, and compute the angle between them, which is then projected out to 50 nautical miles. The other is to again start with the threshold crossing altitude, determine the desired flight path angle, such as 3 degrees, and then calculate the altitude at the final approach fix. Regardless of the method, Jeppesen is required by ARINC 424 to have the glide slope point the aircraft to the threshold crossing altitude. With the glide slope established, the altitude at the missed approach point is then calculated. At the missed approach point, all glide slope information ceases. If you decide to go missed approach, the FMS terminates all vertical navigation and navigates you laterally to the missed approach point, followed by the missed approach procedure. Now that we understand how approach glide slopes are made, we need to look at a couple of situations. Here we have an approach into Sisimiut, Greenland. The approach is designed to get aircraft down to the MDA 3.5 miles prior to the runway, at which point the pilot is to navigate visually to the runway. Recall that Jeppesen is required to have the glide slope take the aircraft to the runway threshold crossing altitude and cannot deviate from this requirement. As a result, the glide slope in the FMS will look like this. Note that the altitude at PIXIV is 1,198 feet, which is 698 feet above the MDA. The glide slope does not follow the intent of the state of origin. What should you do? If the weather's good, you can fly the FMS glide slope to PIXIV and then fly visually to the runway. But if the weather is bad and you need to get down to minimums, you will need to deviate from the glide slope and fly below it. This is not a problem since the FMS is giving you an advisory-only glide slope, taking you down to an MDA. When Jeppesen calculates the flight path angle, they have to take into account any step-down altitudes. If the step-down altitudes in the procedure are below the calculated glide slope, then there is no problem. However, if the step-down altitudes violate the glide slope, then Jeppesen is required by ARINC 424 to recalculate the flight path angle so that no step-down altitudes are violated. It is easy to recognize this situation in your database because the charted and database altitudes will differ. If you were flying this procedure and you came in at the charted altitude, you would begin your descent after the final approach fix. Jeppesen will frequently include much of this information in their charts. Here is just one example. You can see that if you cross the final approach fix at 2,000 feet, the glide slope will be above you until you intercept it at 4.9 nautical miles from the VOR. At that point, you will fly the 3.17 degree flight path angle, which will take you over the step-down altitude. The best way to find out about vertical navigation in the FMS is to use the approach plan page. You will see the waypoints, mileage information, glide slopes, and altitude information. Note that the glide slope going into POSEB is 2.98 degrees. This is valuable information since you will want to know at what altitude you will need to be in order to intercept the glide slope. Prior to the final approach fix, your FMS will use the baro glide slope. Upon arriving at the final approach fix, the FMS must transition to an SBAS glide slope. Prior to the final approach fix, the FMS calculates what the SBAS altitude will be at the final approach fix and executes a smoothing maneuver. Because baro glide slope is influenced by temperature, Your barrel glide slope will not exactly match the S-Bass glide slope unless you are operating on an ISA standard day. This smoothing maneuver enables the FMS to smoothly transition from one glide slope to another. If you are operating SCN 1000.4 or earlier, the smoothing maneuver begins a quarter nautical mile prior to the final approach fix. Later software versions start the smoothing maneuver at 1 nautical mile prior to the final approach fix. Once the FMS has monitored the S-Bass level of service for at least 2.5 to 5 minutes, it will be able to determine its stability and calculate estimated levels of service. As you arrive in the terminal area, the FMS will auto-arm itself. When it does so, it computes a level of service estimate. According to TSO 146, in order to fly an S-Bass approach from the final approach fix to the missed approach point, it must be flown with S-Bass three-dimensional information. So when the FMS goes approach active, it looks at the actual level of service. If the actual level of service is still valid, you continue the approach. This is what will happen almost every time. Let's look at what happens when things do change. When the approach is armed, the FMS estimates your level of service to be LPV. But when you arrive at the capture fix, the FMS alerts you that you cannot get LPV. You can only get LNAV-VNAV. The FMS will push a message which activates the message enunciator. It states LPV not available. You should manually press the Approach Level of Service line select key, which brings up the Level of Service page. From this page, you will notice that LPV is in use, but it is not available, so you must manually downgrade the level of service to LNAV-VNAV. The FAA does not permit this process to be automated. The pilot must select the downgrade manually. If you don't select a downgraded level of service, once you pass the final approach fix, you will be LNAV level of service only, with no vertical reference of any kind, S-Bass or barometric. If you do manually downgrade prior to reaching the final approach fix, you will need to review the new level of service minimums. When the approach is armed, your FMS estimates the level of service to be LPV. When you go approach active, the level of service is evaluated again and is out of parameters for even LNAV-VNAV. How did we lose LNAV-VNAV when we had LPV? We lost contact with the GEO satellites. Without GEO satellite correction data, we cannot use a GPS glide slope. You can still have good lateral navigation, but without an S-Bass glide slope, you cannot get LNAV-VNAV level of service. Everything is good just like before. We select LNAV and press return. What do we use for minimums? You do not have to have an S-Bass glide slope to go down to LNAV-VNAV minimums. An S-Bass glide slope is only required for an LPV approach. As a result, we can continue on down as long as we have the barometric glide slope. What happens when you are outside of S-Bass coverage? Obviously, you will never be able to get an S-Bass glide slope. But if you have LNAV level of service, you can descend down to LNAV-VNAV minimums, provided you still have a barometric glide slope. Advisory Circular 90-105 states that if you have a barometric glide slope, you can descend to a decision altitude. When it comes to vertical scaling, an LPV approach tapers more than other approaches. An LPV continues becoming more sensitive until you get down to plus or minus 15 meters, and then it goes linear.